Today's lesson is on trigonometry, and we're going to add in two additional trig functions to tangent, the one we talked about previously. And the three trig functions that we're going to use are sine, cosine, and include tangent, which we've already talked about. So we have our three trig functions, sine, cosine, and tangent. Sine's abbreviation sin, looks like sin, it's still pronounced sine. Cosine's abbreviation cos, still pronounce it cosine, and tangent abbreviation tan. So we still say the full name sine, cosine, and tangent for each trig function. Now these look familiar. You've probably seen them on your calculator. So in this picture we have a TI, but they're usually in the same place for just about any calculator. We have sine, cosine, and tangent, and these are the three trig functions that we're going to be working with. We're going to use these trig functions to solve right triangle problems. So I'm going to use right triangle ABC. And I want to go over the ratios, specific ratios, sine and cosine, and relate it to tangent. So as we went over yesterday, we know that we're always taking the trig function, the trig value of a specific angle. So in this case, I'm going to work with angle B. So I want to find tangent of angle B. And we know that's equal to opposite side over the adjacent side. So in this case, the side opposite B is going to be AC. The side adjacent to B is BC. And when we talk about opposite and adjacent, we don't use the hypotenuse. We're looking at the legs. Now, for sine, let's still find the sine of angle B. Our ratio in this case is opposite to hypotenuse. So now, our opposite side to B is still AC, but our hypotenuse is AB. So we're getting a ratio of different sides. So our opposite side is going to be side AC. Hypotenuse is AB. Cosine, again, find the cosine of angle B. And cosine is adjacent over hypotenuse. So our hypotenuse stays AB, but our adjacent side, the side adjacent to angle B, or the closest side to B, closest leg to B, is leg CB. So we're setting up three different trig ratios, three different ratios of sides, based on the trig function and based on the angle. Now we want to be able to remember what our ratios are, what our relationship is between the trig function and the sides. We want to be able to remember that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tan is opposite over adjacent for any test or quiz. So an easy way to do that is we're going to look at the first letter of our trig function and the first letter of each word in our ratio. So I have sine, so I have S, O, and H. And then for cosine, we have letters C, A, and H. And for tangent, we have T, O, and A. So we can use it. This gives us a simple mnemonic device that we can use on a test or a quiz. So, ka, toa. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So remember SOHCAHTOA, and it'll help you remember your three trig ratios on tests or quizzes. So let's do one example, just identifying our three trig ratios. So if we have a 3, 4, 5 right triangle. So take a second and set up working with angle A. Find the sine of angle A. So what's the ratio of the sides going to be for sine of angle A, for the cosine of angle A, and for the tangent of angle A? Pause the video for a second and write those three down. So for sine of angle A, we want opposite, which is CB, over hypotenuse, AB. So substituting our values in, we've got 4 over 5. Cosine, we want adjacent, so adjacent to A, we have AC, over hypotenuse, AB. So our ratio is going to be 3 over 5. And tangent, we want opposite, so opposite A is CB. Adjacent, which is AC, so our ratio should be 4 over 3. So let's use our trig functions, in particular sine and cosine, to find missing side lengths. So let's take this example. B is 35 degrees. We're looking for AC, which is x, and we know the hypotenuse is 12. So we have opposite and hypotenuse. And opposite over hypotenuse is going to be our sine function. So I'm going to have the sine of my angle, 35 degrees, equals my opposite side, x, over my hypotenuse, 12. Now using our calculator, we can find the sine of 35 and round the value to 4 decimal points, so we'll get 0.5736. You can also get this value by using the table of trig values that was provided to you the other day. Equals x over 12. Now to get x by itself, to multiply both sides by 12. And we get x equals 6.9 if we're going to round our decimal, our answers to the nearest tenth. Now we can also use cosine to find the value of x. We know that if we have 90 degrees here, 35 degrees here, we know angle A has to be 55 degrees. So now we could use adjacent and hypotenuse. So I can have cosine of 55 degrees equals adjacent over hypotenuse. So the cosine of 55 degrees is 0.5736, so the same as the sine of 35 degrees, its complement. And then if I multiply both sides by 12 and 12, we'll get the same answer, 6.9. So we can solve for x using the sine of 35, and we have opposite and hypotenuse, or cosine of 55, and we have adjacent and hypotenuse. So let's do another example. So again, we have triangle ABC. In this example, angle A is 58 degrees, and x and y are legs, and 120 is the hypotenuse. So I want you to use both the sine and cosine trig functions to find the value of x and y. So take a second, pause the video, and find the value of x and y. So I'm going to find x first, and x is opposite and hypotenuse. So opposite and hypotenuse, I'm going to use sine. So I have sine of 58 equals opposite to hypotenuse. The sine of 58 degrees is 0.8480 equals x over 120. Multiply both sides by 120. And we get 101.8, rounding our answer to the nearest tenth. Now, let's solve for y, and y in relationship to 58 degrees is adjacent, and then we have the hypotenuse, so we're going to use cosine. So cosine of 58 equals adjacent to hypotenuse. Cosine of 58 is 0.5299. And again, we could use our calculator to figure these values out, or use the table of trig values that I gave you. Equals y over 120. Multiply both sides by 120. And we get y equals 63.6. So we can also use our trig function to find missing angles if we know our sides. So in this case, we're going to look for angle y, and we have opposite and hypotenuse, 22 and 50. So opposite and hypotenuse is sine, so I'll have sine of angle y equals opposite, 22, over hypotenuse of 50. Now we're going in reverse. Instead of finding the sides, we want to find the angles. So we have to use the inverse sine function. So on your graphing calculator, we have the sine, cosine, and tangent functions. Right above them you see sine to the negative 1 power, cosine and tangent all to the negative 1 power. These are inverse functions, so you're going to have to hit your second button, and then sine, cosine, or tangent to activate that function. It basically means you're looking for the angle instead of the side length. So I have opposite over hypotenuse, so I'm going to use sine, the inverse sine function. And I want to use the inverse sine function of my side ratio, 22 to 50. So if I divide 22 by 50, I get 0.44. And the inverse sine of 0.44 is going to be 26 degrees. Now you can use your graphing calculator for this, or you could use the table of trig values that I gave you and figure out basically where the sine, at what angle does the sine equal 0.44. So let's do one more example. In this case we're looking for x. We have 11 and 28. So take a second, pause the video, and use your trig function to find the value of x if AC is 11 and the hypotenuse is 28. So my sides are adjacent and hypotenuse. Adjacent and hypotenuse is cosine, so I'll have a cosine of my angle x equals 11 over 28. Since I'm looking for the angle, we're going to have to use the inverse cosine. So I'll have cosine the negative 1 power. And then 11 divided by 28 is 0.3929. And if we enter this into our calculator, the inverse cosine of 0.3929, we're going to get x equals 67 degrees. And again, you could find this value by either using your calculator and entering the inverse cosine of 0.3929, or using the table of trig functions and just finding this value as close to that value as you can, 0.3929, in the column for cosine, and figure out what angle that corresponds to.